Hi, so this is the second video on my series, Connected Particles with Inclined Planes and Friction. So in example 2, we're told that two objects, A and B, of mass 6 kilograms and 8 kilograms, are respectively connected by a light inextensible string. The objects are accelerating up a rough plane, and the pulling force causing the acceleration has a magnitude of 240 newtons, and acts on A in a direction parallel to the plane. The coefficient of friction between each particle and the plane is 0.6. We've been asked to find the acceleration of A. We can treat each of these as a single object. So if we create a new sketch, we know the combined mass will be 14 kilograms, and this will have a downward weight of 14g. There'll be a perpendicular component where this angle is 30 degrees, and the perpendicular force is 14g cos of 30, when this angle is 30 degrees, and the downward force parallel to the plane will be 14g sine of 30, and the 240 newtons will be pulling the mass up the plane. But we also know there'll be a friction opposing the plane, and we can work out this frictional force by adding the friction at A separately to the friction at B. We know these were two different forces because their normal reactions we'll call RA and RB will be different. So the next step is to work out RA and RB. So we know this 6 kilogram mass will have a weight of 6g. Its perpendicular component will be 6g cos of 30. And for object B, we'll have a weight of 8g with a perpendicular component of 8g cos 30. So now we've got our normal reactions, we can work out the friction at each of these points. So the friction at A will be mu, which we're told is 0.6, so 3/5 of a normal reaction. So this will be 0.6 multiplied by 6g cos 30. We can work this out as 0.6 times 6 times 9.8 times the cos of 30. And this will give us 30.55 newtons. So then for the friction at B, we know FB will be 3/5 of a normal reaction of object B, so 8g cos 30. So this will be 0.6 times 8 times 9.8 times the cos of 30, which is 40.74 newtons. So the total frictional force will be the sum of these two, which is 71.29 newtons. Okay, so now we've got all our forces, we can resolve parallel and up the plane, because this is the direction of motion. We know the tension, this tension here, minus the two opposing forces, 14g sine 30, plus the 71.29, will have a net force of 14 times the acceleration. So if we add these two together, we've got 14 times 9.8 times the sine of 30 plus the 71.29. So the tension minus 139.89 will equal 14A. And we know this tension is 240 newtons. We can work this out as 100.11 will equal 14A. We'll divide both sides by 14. So the acceleration will be 7.15 meters per second squared. Okay?